Howdy, everyone. We are Team 7. Consists of, I'm Cameron Berger. We have Tristan Furick on the call, Jacob Lent, and Ian McDonald. And we are tackling a grain elevator dust collection system. So this is a United Ag elevator that's in El Campo, Texas. And they asked us to look at their dump pit and try to give them some ideas for dealing with particle matter dust emissions that are present at that specific dump pit. So what's on the agenda today, we're going to discuss our flow analysis and go through some of the potential solutions that we're currently looking at. We're going to walk through our decision matrix and explain the criteria that we've been basing our weighting these potential solutions on, discuss our selection analysis, go into detail about differentiating between these solutions and their pros and cons of each. We're going to wrap up with our conclusion and open the floor for any questions from you guys. So in our flow analysis, we're just looking at things that are going through our system that are of concern and importance to us. Specifically, the ones listed that we're addressing are trucks, the people, the grain, obviously through this elevator, electricity present, and the airflow. So on average per day, this El Campo elevator sees about 10 trucks come through and drop into their dump pit. And these trucks are bringing in about 1,000 bushels of grain each. At least that's the capacity that they're able to carry. The people that are in the system that we're focusing on, there's two of them specifically. We have an operator. That's the person that's controlling the movement of the trucks through the dump pit and whatever electrical controls are manipulating the pit. And then we have what's called a truck buster. This is somebody who's running out and opening that hopper on that truck that's releasing the grain into this dump pit. And so we have the grain, obviously that's flowing through the system. And when discussing with United Ag, they said that they see about 10,000 bushels a day through the system. And this is from around a 2 million bushel per year throughput that we discussed with them. The electricity that's flowing through the system, as I mentioned, is coming from those electrical controls that is controlling that dump pit and what else that's moving that grain through the system. And then the air that's running through the system, that's important because that flow is what's moving this particulate matter around. This is those dust emissions that are coming off of that agitated grain as it's being released from that hopper into this dump pit. And that is our area of concern that we're looking at as far as the exposure to workers that are in this area, as well as the pollution to the air outside of the facility. So some of the possible solutions that we're going to be discussing today is what's called a baffle system. We have a garage door solution and a hopper sleeve, and we'll go into detail on those shortly. But first, I'd like to show you guys our decision matrix and kind of explain how we broke these down. So the criteria that we're looking at here, comparing these solutions, are efficiency, cost, and effectiveness. When we are talking about efficiency in this context, we are talking about how the system is functioning in comparison with our system, how our implementation is functioning with our system already in place, ensuring that it's not prohibiting any movements and that it can be introduced in a smooth manner. Cost, we are considering both implementation and maintenance costs when we're looking at that criteria. And effectiveness in this context is relating to how these implementations address this issue of the pollution, the dust pollution, the particulate matter that we've been discussing. These are weighted according to how we see priority. So we think that effectiveness, how it's addressing the particulate matter pollution, that's going to be the most important criteria here when we're weighting these solutions. And the scales that are here, the 1 to 10, things that are being rated at a 1 would be the least efficient, least cost effective, least effective in addressing in the environmental pollution, versus 10 being the most, the better of the two. So going forward, Tristan's going to take over and start discussing our first potential solution.
Thanks, Cameron. So the baffle system is created by, or it's made by the Controlled Environments Group LLC. They specialize in dust control and suppression systems, and they have been for about the past 2 decades. The way this baffle system works is it's gravity fed, so there's no power requirements, or there's no electrical requirements, or any kind of manual operations. But what it is it's these cones, and as the truck drives up over the pit, which that picture right there you can see, and the truck buster opens up the hopper, the grain will actually push those cones open and flow down into the auger system. And then whenever the hopper is empty, whenever all the grain has gone back through, the cones will seal back off, and closing off the system. So really all it does is it closes the system to make sure that the system isn't open to the atmosphere, and dust can be pushed back through, and dust can get out that way. The way current systems work is it's literally just a hole. It's a hole that the auger is open to. Obviously, it's got a safety grate, as you can see in the picture. You can see them on the sides there. So when the dust is going through, that auger is just spinning and running, and it creates dust, and then that dust gets released out into the atmosphere. The baffle system pretty much just is a gravity-fed door, in simple speaking terms, that will shut whenever the grain's all the way through. Cameron, can you go on to the next slide, please? Awesome, thank you. So we went ahead, our team, we went ahead and we kind of analyzed the baffle system. And as far as efficiency goes, it is pretty efficient since there's no power or electrical components needed. So you don't have any maintenance for the motor, or if your motor goes out, it's not going to affect your unloading and your production. Cost, it is very cheap. It'll cost about $5,000 to $10,000 with a contractor, and Controlled Environmental Group. They have a list of contractors that they'll use or that they will approve to install it, because all it is it's cut and remove concrete, and you're placing the new system in. So it's a very cheap option. And it's very simple. There's no power requirements, like I said, so you're not having to worry about power outages or motor requirements or anything like that. As far as effectiveness goes, there is still about 2 to 3 feet of openness from the top of the baffle to the bottom of the truck hopper. So as that grain falls, it is free and it's open to the atmosphere, so dust can still be emitted and escaped while it's falling. So that's why we kind of went with a 5. It's one of the least effective out of the 3 solutions we came up with. So in total, we rated it about 7.5, 7.66. What we really noticed and what we thought was this would be a great solution that you'd pair with another one, just because it is so cheap that you're really not losing a whole lot as far as a budget requirement goes and things like that. But Jacob's going to go ahead and talk to us about the garage solution.
So I'm going to be covering the garage door solution. I'm going to be going over how it works, what are some of the benefits and the drawbacks. So just kind of start us off here in figure 2 and 3. It's an example of an enclosed grain elevator unloading pit. I got this from a company called ESI. So our solution will look something a lot like this, a lot similar. So just for reference, those 2 figures are there. So let's go over how it works. First, an enclosed building with 2 garage doors will need to be constructed around the grain unloading pit. Once that building is constructed, the garage doors will always remain closed when no unloading is taking place. When a grain truck arrives, the pit operator will then open the first garage door. The truck carrying the grain will then enter the building and wait for the pit operator to close the garage door again. Now with both the entrance and exit garage doors closed, the truck buster employee can get up there and begin the process of unloading the grain. After the grain is unloaded, the garage doors will remain closed until the fans that United Ag already has in place. So there's going to be fans inside that enclosure. It's going to be sucking up all the dust and transporting it to a cyclone that's also already on site at United Ag. So all that dust can be filtered further. Once all the dust is collected by the fans, the pit operator can open the second garage door for the truck driver to exit through. And then once he's left, the pit operator will then close the garage doors again. And like I said earlier, both those doors will remain closed until the next truck arrives. So some of the benefits of this solution, United Ag will benefit because it will limit the amount of dust emissions currently present within the grain elevator and loading pit if implemented. It's easy to construct and operate. It's fairly simple, and it is relatively inexpensive to implement, costing around anywhere from $5,000 to $10,000. Some of the drawbacks, if used improperly, dust emissions could potentially increase. So what I mean by that, if both garage doors are left open during the grain and loading process, the effects could create a wind tunnel that would increase dust emissions. That wind tunnel would severely just blow out more of that dust. So that's one problem that could potentially occur if used improperly. So another potential problem is the fact that the truck driver, pit operator, and truck buster will all be inside the unloading area when the grain dumping occurs. They'll be exposed to a large amount of dust confined within a small area. So the proper PPE will definitely be needed in order to prevent any health problems for the employees. With that, I'm going to kind of move on to the solution analysis of this portion of the solution, or selection analysis, sorry. So I'll be going over efficiency, cost, and effectiveness, and overall total. So let's start with efficiency. Due to the need of opening and closing garage doors and waiting until all the dust has been removed after the truck has completed the unloading process, our team ranked this solution's efficiency as 7. So the added time to the unloading process is really what impacted this decision the most, since it reduces the efficiency of the overall unloading process. Moving on to cost, the garage door solution is ranked 8 due to its affordability. The only costs present are labor and relatively cheap materials. With the fans for further filtration and cyclone already on site, this solution would be very easy and cheap to implement. The structure itself will also have a longer life of use when compared to the other solutions, just due to its ability of handling wear and tear over time, since it is constructed in order to withhold weathering and outside environments. So the overall effectiveness, finally, the garage door solution is ranked 9 in its effectiveness, giving it a total ranking of 8.25, which is the highest overall ranking within the decision matrix. This solution is able to really mitigate a drastic amount of grain dust emission by trapping the dust inside the pit and removing it through air ducts with fans and a cyclone already in place for further filtration. So this solution seems to be a real great option moving forward when determining a cheap and efficient solution for United Ag. And with that, Ian will go ahead and wrap us up with the final solution.
All right. Our final solution that we have is what we're calling a hopper sleeve, which is basically a canvas or soft sheet material tube that clamps or cinches around the bottom of the hopper on the truck to allow a funnel to go straight into the pit, thus not allowing the flow of the grain to be exposed to the atmosphere at all and keeping the dust contained in that flow. A couple of benefits are it's simple and easy to use. It basically will either swing under and clamp to the truck or roll under and clamp to the truck. However, we do not have a vendor. We've not found a vendor yet for this solution, so most likely we will end up having to find someone to fabricate it or fabricate it ourselves, which is going to bring the cost up, which brings me to our selection analysis of this. Overall, we rated the efficiency at 9 because it is such a simple system that swings under and it does not change any other aspect of the grain pit itself. It's just an easy plug and play solution. However, like I mentioned before, the cost is a little higher than we would like. That is just due to the fact that we will most likely be having to find a way to fabricate this. But after this becomes a standardized solution, we expect the cost to go down, which will bring its total ranking up, and I expect it to take over as the top solution. Its effectiveness, however, we ranked it at 8. That's because it is such a simple solution. It contains the flow of the grain at the source, and there minimizes what is exposed to the atmosphere, which gives us a total ranking of 8. And it is the number 2 solution in the matrix. to wrap it up, we have some stuff left to do with our project. Biggest thing right now on our table is finishing up our flow analysis. We got to do a little more research and take care of that, get it all finalized. And then we're going to be looking at starting up our economic analysis pretty soon, which means we will be looking at a final solution. We'll be working with Stephen and United Ag to see which solution or which set of solutions they want to use. Tristan mentioned that we could, there's a potential that like the baffle could be used in addition to another system. Even all three systems could potentially be used. That's all we have, and now we will open up for questions.
Okay, thank you. Stephen, do you have any questions or comments for this team? Looks like Stephen's not on microphone, so that's okay. You can just make your comments. While we're waiting on Stephen to dial in, let's go to the peer team. Team 4, you want to make some comments?
Yeah, I like how y'all put the decision matrix and highlighted each part for each solution. I thought that was really smart. So you kind of followed it all the way through. It's not just one slide and you'd have to keep referring back to it. It's in that slide. So I thought that was really smart. And the transitions too. Those are all good.
Thank you. Appreciate it.
Anything else?
I mean, I like that. I did really good on like numbers and stuff in y'all slide, but have y'all like put in there, because I've worked around a lot of these, put in there like on the garage door system, like the 18-wheeler getting stuck in there with all the grain dust. I mean, have y'all looked in like the downside of all of these too? Because you think about it, all the 18-wheeler drivers are not going to sit in there and their 18-wheelers, air filters all get stopped up. I just wonder if y'all weighed in like the downsides to these operations.
Yeah, that's true. That's something that I was looking at whenever I was kind of developing that solution. There's a couple different things they can do. I mean, if they don't want to sit, I guess, in their 18-wheeler, they could potentially get out and just kind of turn off the engine completely and just kind of leave while that whole process of unloading is happening. It's one way, but yeah, obviously that is a big downside with everyone being inside there with all that dust trapped in there. So that is something that if we do move forward, we'll have to solve. As of right now, my best solution was just PPE, just masks, whatnot, what have you. So yeah, but that's definitely something that we'll have to look into further if we move forward with that.
To kind of add to what Jacob said, a big thing is with our decision matrix is just because it's ranked higher might not be what we actually go with. I know with the garage door system, the vehicle, the 18 with the semis that are going to be will have to be turned off because that safety hazard. There's obviously there's combustion. There's it's a spark source in there, and with all that concentrated dust. The truck would need to be turned off just so that a fire doesn't happen. The dust doesn't combust. So, we're weighing in the safety aspect and all that into the decision as well. But I just wanted to throw that in there.
Yeah, that's a good point. I'm dialed in now. So, my phone's been going off the hook all morning dealing with some other stuff. But, so yeah, that's a good point you just said there. I would say you might want to add in one more, column on your decision matrix and just factor in that safety unless you're rolling that into effectiveness. But whoever said it last kind of took the question right out of my mouth. Definitely want to consider two options as well. I think obviously the garage door, we have one at our port facility, and I'll never put a building around our pit ever again with the experience that we've had down there. So we can discuss that. And the cost is going to be much higher because yes, we do have a fan on site right now, but once you enclose an entire pit area, if you add additional ducts to that pit, you're going to have additional fans, larger cyclone or dual cyclones. So your cost kind of gets raised pretty quickly there. But I think, looking at y'all's presentation, if I was gonna make a decision today, based on the information you guys provided, I'd be going towards restoring our existing cyclone and fan dust pool, and then coupling that with the I forget what y'all called it, not the baffle, but the
The
cone,
hopper.
the hopper, the hopper solution. So I think that would be the way we'd probably be moving forward. So overall, presentation was pretty good. You guys bounced back and forth well. I think put a little more effort into the dual option. There's not always just one solution to any problem. So I'm glad that was mentioned there at the end.
Okay, thanks, Stephen. Dr. Castell?
Yeah, I have to say, this is, for me, so far the best presentation I have seen in class. So much more improved than your first one. So congratulations, you did a great job in distributing the assignments. The content had wonderful flow. It answered all my questions. I understood everything you said, explained everything in detail, so I didn't come up with 100 questions, why this and what that. So my compliments to you, very well done and presented. I had only a few comments on the description of the solutions, the buffer system and the garage door. I'm sure you know how it works, but I was stuck looking at a picture. And Tristan, you do what I always do when I'm teaching. You were using your hands. So I was watching you describing how it works. So that was distracting. So I don't know. I keep saying, I don't know if you can use the pointer, or so, but I know it's difficult from Zoom, but it's distracting because I had to watch Tristan's hands. And again, I do the same thing when I'm teaching and I forget people don't see. So maybe some schematics on how they work will have helped me a little more on this, even though your explanations are very good. So good job. Ian, I don't know if you were looking away from the camera, so I don't know if you were reading from notes. So I noticed that, and it's a little distracting. You have a very good voice, but that was distracting to see you looking. You were looking at somewhere else. So pay attention to the camera. I know this is a Zoom. Overall, I don't have anything else to say. I was very impressed. Very good job with Team 7. Thank you.
Okay, thanks. Yeah, this is a good presentation, 16 minutes long. Cameron, a whopping 5 minutes is what I counted, but you did the overview and really took your time on the flow analysis. No problems at all there. Tristan, 3 minutes. You must have a really good microphone, or maybe your voice is just a radio quality voice. Your voice sounded really good. All of you did good. Jacob, your knowledge of the system was impressive. You easily communicated what you knew. Ian, yeah, good job, all of you. Good presentation. I appreciate you being ready. Your organization was good. Your transitions between each one, and I agree. Having the potential solution followed by the selection analysis.
Yes. Very good.
That worked out really well. Whose idea was that? Come on, somebody take a bow.
I think that was Tristan's, right?
Yeah, we kind of all thought about it and talked about it. We were trying to figure out a way to distribute the time each person talked accordingly, so try to make it even as possible. But we also wanted everybody to talk about the solution that they found and research, just so we would have a person that knew the most, had the most knowledge about the solution. So that's kind of how we ended up with that. But I don't know. We all kind of worked through it together.
Yeah, now I appreciate y'all. Here's what I like about that. You used some initiative, you used some innovation, and you didn't just keep yourself in the box that we built for you. And that worked out really. When you first did that, I thought, oh no, what are they doing? And then I thought, wow, that worked out really well. So that was very, very innovative. Okay, let me hit some critiques. The flow analysis, I appreciate you trying to come up with some numbers. That still needs a little bit of work. Probably the most important thing, I think, like I put on your paper, Cameron, is I don't know that electricity is really, yeah, electricity flows through the system, but it's probably not one of the top 3 things that's going to affect your solution. When you talk about the grain that's coming out of the trucks, there's a term that we use called dust loading. How much dust is actually in the grain, like 2 grams per cubic centimeter, that sort of thing. You could actually estimate the the mass of the dust coming out. I'm not sure that would be all that useful, but I could help you do that. Probably the biggest critique I have is, like, for example, let's go to Jacob. Jacob, your slide on the garage door. And I like the fact that you had a format here that you all followed. How does it work? What are the benefits? What are the drawbacks? How about having a slide for each one of those bullets? I felt like you spent too long on here when you could have helped us with the how it works and what are the benefits, advantages and disadvantages. Could have had its own slide to help you out there a little bit, okay?
Okay.
Good pictures. Sorry about that. I owe somebody up here. I have my phone going off during the presentation. So anyway, that's my only comment there is I would go ahead and use the freedom to give yourself, you talked about 3 minutes on this, so I'd give you about one slide a minute and you could have hit each one of those. Good pictures though. That's all I'm going to say about that. Any other comments? Jan, you want to say something?
Well, I do have one question and one comment. So my question for camera, I see a new term that I'm not familiar with. Is the bushel grain? Is that how you call it? What is that unit, and how does it refer to like more common metrics that you see every day?
Okay, I'm sorry. I think I'm just a little hard of hearing on my end because of my computer. So, explaining the bushels per grain or bushels of grain. Does anybody remember the pounds in a bushel? It
should be right around it.
What is it, Ian?
Yeah, a bushel is a volume measurement where, and I believe there's a bulk density. I think for wheat would be like 45 pounds per cubic feet or something like that. I think so. What Yang is asking. Now, bushel is a term that we're all familiar with working in Texas, in the United States. It's an English unit. So he's asking for the SI unit equivalent.
Or something like that, because this is my first time seeing this. But yeah, I don't think that's a big problem, but I'm just like curious. And I do want to follow up the comments from Dr. Castile and Colonel McGee about the potential solutions. Can you go to one of the solutions you have? Yeah, so I agree with Colonel McGee that you follow the same kind of pattern to explain each solutions. And for one slide, it really don't stand alone. Of course, your verbal explanation is pretty well, but when I look back to the slides, I really don't, if I forgot it, I don't remember what you're talking about, and I don't understand this section at all. But instead of putting one pictures, maybe you can add some animations or short clips. You can do the embedded like videos in the PowerPoint slides, and that will help you a lot by demonstrating over like internet that you don't have your hands or you don't have a pointer to show how it really works. Yeah, and that's something that I will cover in practice soon. But since you brought it up, maybe that's something you can improve a little bit next time.
Yeah, I'll make a comment about that. I did look for any kind of animated clips or anything or an actual video of the baffle system working, and I couldn't find anything. So, I mean, that's just going to kind of be upon the availability of what you have. And we didn't have any kind of resource to be actually make a firsthand video. But I did look for a video or something like that, and I wasn't able to find something that worked the way this baffle system does, or else I would have included it.
I see. That's a very good answer. And that's all my comments. Very good job.
Yeah, good job. Yeah, maybe a cross section. Okay, Steve's got the density of the grain. Okay, good. But yeah, maybe remember we gave you a little tutorial in computer graphics. So maybe just a cross section of what that looks like. Just kind of draw it out, or some measurements. But yeah, we're into the weeds. So good presentation. Let me ask you each. We'll start with Cameron. What improvement did you learn or that you need to make from your self-critique? Tell us what you wanted to make better.
I'm sorry, going forward or from last time that you?
You watched your last presentation, and what did you say? Here's what I need to do better on my second presentation.
So I needed to be more thorough in explaining figures or tables that I had on my slide. Also, the usage of filler words like and then the last thing that I noticed, I can sound out of breath because I'm not focusing on breathing while presenting and I speak too quickly.
Okay, good. How about you, Jacob?
Yeah, so I just did it right there. Filler words. That was a big one for me. I did a little bit better of a job, but that's something that I still need to work on. And then the last presentation, watching it, I had my hands kind of on my mouth and whatnot, so I tried to not do that this time around. So I think that helped out a lot. And then just going over and practicing my slides more than I did last time, so that helped as well.
Okay. Tristan, how about you?
From last presentation, I think I just did it right there. But I was really wanting to work on picking out filler words and work on being more fluid in my conversation and how I present myself and speak. I did notice this time I think I probably spoke a little quick, which would, impair y'all's ability to, kind of understand and actually process what I'm saying. So I might need to slow down a little bit for the next presentation.
Okay, thanks. I want to address Stephen's comments in the chat here. Now, Stephen was an Ag Systems student, graduated in 2011, so 10 years ago, and he's been out in industry, and he's quickly seeing how important it is to, be able to do, the math here and convert things and all that. And yeah, typically when you're writing a professional paper, which I'm not sure this really is what we're looking for here, when you give an English, usually you give the units in like English units, and in parentheses you put everything in SI units. We haven't required that here, but as you can see, it is a pretty standard industry practice. We may need to consider that. Any comments on that?
No, I agree. I always emphasize that in 315 because some readers might not be familiar with the unit, so just make it easy for the readers.